Welcome to today's developer meeting. We have 3 items today, the user interface, the climate control, and the machine learning part. And we decided, hey, there's Rebecca.
Hello. Hello, Rebecca.
Hey ho.
So we decided to start with the user interface. Let's see, there are more people in machine learning right now. Shall we start with the machine learning instead?
Maybe we should make a mic.
Actually, that would be great.
Yeah,
Mike
so-
is missing, but it would be great because I'm not sure that I can make it all the way to the end of the meeting,
All right.
and I have a window of opportunity now.
Okay, fine. So you posted the
Yeah,
PowerPoint.
can
and
I talk about that?
Yes, of course.
Yeah.
I want to show that. I share it because
I'm going to show it so
you're gonna share
I can
it. Okay.
I can control more.
Okay. Perfect.
Okay. Let's go. So, does that work?
Not yet. Loading.
Not yet?
No. Did you share a window or a screen?
Window. Okay, I'm
Try
going
to
to
share
start
screen.
again. Screen. Can I share the entire screen? Okay, I'm going to share the screen. Entire screen. Let's go. Up. How about that?
You have to say okay.
No?
Not at the
No.
moment.
No, it said the stream has ended.
Do it
No,
again.
still no.
Nothing.
Just do it again.
Yeah, but it's never worked for me.
It is locked for you?
Now it's it says it's sharing and then it doesn't share.
Okay, so shall I open it?
Please.
Okay. In that case, I have to share. Hold on a sec. There it is. And then I have to share the screen. This is complicated. So that one.
Complicated because you are old, buddy.
Shut up! Oh my god,
Okay.
we are recording.
Works for me.
So here it is. Sorry, here it is.
Okay, there we go.
Okay. So
Interesting.
So first thing I wanted to say was that the tracking of an object in the field of view, that works just great. That's perfect. So you can see you can barely see what's interesting, but the system did see it. So great work by Mike and Paul. Can you go to the next slide?
Yes.
Okay, so see, you can barely distinguish the object when the system picked it. Okay, next slide. See, it's a tiny plane, but it's a low-flying plane, and see it's tiny stuff in the big picture, and still it works. Okay, next slide, please. And I overlaid the track. And then there's the program output. So we can work with that, no problem. Next slide, please. Again, the next one. Yes. Okay. So with this string of bounded box, we can draw vectors. So that's no problem, and we can classify the vectors, but that's where it gets complicated because that happens after the classification. So that happens after the entire track.
Mhm.
So after the object has been tracked, then you can classify it, and you don't have the opportunity to drive the PTZ from that track because the object is already gone.
Mhm.
So oh yes, and also so here I got 3 dimension, and I can make some clustering out of those 3 direction, and we could add dimension. That's not an issue, but what? That's my question on the next slide.
Mhm.
Is what else can we add that's relevant? I don't think time of day or weather. Well, time of day, I'm sure it's not relevant. Weather could be, but I don't directly see how.
Mhm.
And the bigger problem that I see is on the next slide. Is that you cannot use time series because you don't know what's going to happen next.
Mhm.
So see, it's that's not the time series is not going to help you drive the PTZ. Then there's another problem. If you can click on the slide. And the other problem is that if it's the ISS, too small, you cannot do any feature detection because it's going to be, if I understand, it's 2 by 2 pixel or
Yeah.
it's tiny. So there's no way you can do anything. Well, I don't see how you can do anything interesting in terms of recognition with the 2 by 2 pixel.
Mhm.
And then there's another paragraph in the same slide, is that if you if you teach the model from one station data, it's going to be too little data to actually build some intelligence. So I think that we should organize things right away. That every track, every feature, every video that's interesting gets uploaded. So that's more of a architectural aspect, but it's got to be cloud based. Otherwise, we cannot build the training data. So the power of the system must come from the distributed, from the wide array of data that we will build, but that means that everything's got to be uploaded to the cloud as much as possible.
So the idea is to have not everything, but a subset, let's say, that is hand checked, checked by a human eye and hand, and put on a Google Drive. So that is
Yes,
data
but
that's already classified by humans, let's say, into planes, birds, and so forth.
so having it classified by a human
Yeah,
on the station level,
yeah.
well, how can we know that somebody that deploys a system is going to? We cannot rely on the users to make the classification. They will miss things or they will not work.
No,
And
no,
if
no.
they see something interesting, maybe we won't learn about it. So I think in an early phase, it's really important to have a central repository for data
Yeah.
in order to build the training data. That's,
Yeah.
to me, that's crucial. It's not going to work if we don't have a lot of training data, and it cannot work on a per station level. But that's what I've been thinking this week. And then there's another problem in the next slide, is that actually, see, that's those green squares. That's a low-flying airliner. That's a plane that's not that high. and you barely can distinguish it. And using those bounded box, you want to point the PTZ. So that's my understanding of the PTZ, is that you've got the red square that you've got to align with the next green square, and you don't know where the next green square is.
Yeah.
There's no way you can know where the next green square is. And it's got to be insanely precise where you place it. Otherwise, you're not going to leverage the PTZ. It's just going to point at some cloud. It's not going to like if we take this example of the aircraft, it's really hard to point that red square to the next green square of the aircraft.
No, it's not, because the BTTS system is that agile and that precise that it can do it.
Which system?
The tracking system. The
So
PTZ is
the
driven
green
by
square.
BTTS, and it's the tracking system, and it is designed to do exactly that, and it does that. Because we do not. The problem is that this data you've got is from Skyhub, and at Skyhub you've got a different old Skycam setup, because the Fisheye Camera and has a different size. It has other pixels. So for the system we are designing now, this is not really true, because we have got much more resolution. We have got more pixels, or we try to have more pixels and more smaller pixels, so that we can determine the position much better. And giving that to the PTZ head, because it makes use of BTTS, then we can slew the telescope very, very fast to a position. And therefore we have got the classifier and the prioritizer that decides what target is heading is chosen for the PTZ next. And therefore we make use of nearest neighbors, or we use the traveling salesman problem to solve that. So this is in development.
Basically, it's so that the PTZ material is for recognition of the events and pre-classification and prioritization. At the moment when the event is brought over to the PTZ and told the PTZ where to point to, the PTZ can pick up the tracking by itself. It's not a permanently, the Skycam permanently guiding the PTZ. It's just for the initial event, how you say?
Yeah, okay.
Command,
The first few bounded box.
Yeah. So it's a little bit more complicated. It's, you see, you draw some you draw this green vector with some bounding boxes. So let's say this is 6 frames of a video, for example.
Yeah, actually it's about 20.
Or 20 pixels, okay.
20 frames, 20 frames, 20 bounded box.
Yeah. So let's say if with the first 5 frames, it is clear that the vector is stable enough to make an estimation where it will be in the next frames. It's just an estimation. Then if we check with the PTZ and where it is actually at the point heading to, then we have to calculate how long does it take for the PTZ to swing around towards this event point. And so in the future, we have to find a point in the future where they both meet.
It's like an interception course.
Genau.
This is done by militaries all the time, so it's working.
So are you trying to so does it like fit a function to the vector?
More like some kind of multiple regression.
Okay.
Because it's faster.
Okay.
And
So,
it doesn't consume that much power from the CPU.
Okay.
Yeah.
And there's no, because I wasn't aware of this system. Is there a channel for it, or?
It's currently
Of-
in development, so it's not
No, PT3
set
now.
in stone right now, right?
He mentions PT3, right? B triple TS, sorry.
P-
B triple.
B
Yeah.
triple TS.
Yeah.
So there's no
No
channel
Discord
in
channel for
Discord.
that, because we don't need any of that channel.
Okay.
So-
Well, it'd be nice to have some to be aware about it, to
Yeah.
have a bit
Yeah.
of documentation, because I learned about it today.
Yeah, right. Actually, we put it up in the system schematics where we explained it.
Okay. Okay, I'll review those then.
In the overview, it is there.
Okay.
Christian, would it make sense to put the repository public for BTTS?
Not at the moment, because we have changed some things to use it with Sky 360. At the moment, it's more focused on astronomical stuff, and that reduces the speed. And we have to upgrade the scaling for the micro steps. So to get it much quicker, because we said, okay, we want to try to have the system half across the sky within 4 seconds. And to achieve that, we have to speed up the acceleration process.
And that's a task that only you can do at the moment, right?
Yeah, because I know it best.
Okay.
But I know where what to take out and where to put some work in.
Yeah, good. But at the moment, as long as we do not have the PTZ, and we do not develop right now because we have postponed it into summer, it doesn't make sense to have that ready for now, right?
Yeah, we are focusing on the old Skycam and to track material there.
Yeah. So Lionel, I have questions. First of all, this idea is great, absolutely, especially when you can make a classification like that one.
Well, it's more like it's more questions than ideas, really.
No, absolutely. It's about the idea that you find a lot of problems on this route. Absolutely, I'm convinced. But the idea per se is great, because the normal neural networks works on images, on image recognition, and not on the physics, because it takes just one frame and one picture and analyzes this one, but not the change of the pixels over time. And that's why I think such classification is a very valuable point that we should absolutely integrate. I see
Okay, well, it's okay, thanks.
I see it as a contribution to the decision-making process, so the prioritization process. So
Yeah, that's yeah, okay.
It
Yeah,
gives more confidence.
it's going to have a factor of certainty.
Yeah, exactly. Yeah, it enhances some factor of certainty, right? So if the machine learning says that looks like a bird, but then we can also say, yeah, but it also behaves like a bird. Or if machine learning says it's an unknown, but your classifier says, but it behaves like a bird, then maybe the machine learning can give more credit to, or the decision making can give more credit to a known event. But it also can be an unknown that behaves like a bird, of course. So we have to experiment with this. We have to see. No one ever did such thing. So we have to develop and experiment with this. But for all, I say it's a grand idea, and you certainly should follow this.
Yeah, well, it's yeah, okay, thank you, great. I'm glad you like it.
I'd also say that it's not only after an event. Let's say you have 20 seconds something flying overhead. It is valuable from the very beginning, from the very first frames, when you already know, it could be this or that bundle of things we normally see.
Maybe we should set a window of identification let's say 3 frames or 1 second, and to
For
make
example.
the decision in
Yeah.
that time frame.
Yeah, kind of, yeah. Good idea. And then you can
when we first started about thinking how to combine the PTZ or make use of a PTZ, we thought about that, and as I recall, Richard and me had about, let's say, 1 month of discussion how fast we could slew the PTZ to the point, and how long it will take to reach a certain point above the horizon. And we came up with a speed of at least 20 degrees per second as to be safe. And so we thought about that, and it's good that you got some values that supports this thoughts. And we have to look into it and how an object, how a detection changes over time to see if we can get a better prediction for the interception course.
And even your evaluation shall roll during the whole event, not only at the very beginning. So when you say from the very first frames, okay, it's with 70%, it behaves like a bird, and you follow it, this estimate can change over time. And that's certainly something we should keep in mind. So what I want to say, something can show up and look like a bird or a star, but then turns out to be something different, because then it starts moving, for example.
Yeah, but making the predictions about that. Let's say we have a bird that is classified as a bird and behaves like a bird. Then we can predict a movement path and see if the object is following that path. And if we have something that is classified as unknown, behaves like a bird, but doesn't follow its path, then we know, okay, it's unknown. And this will help over time to make the right pre-calculations for it. So this is very, very valuable input, and we should try to improve the diagram we have here and see if we can get for every classification label some standard movement path.
Yeah, I understand. Yeah, that's
So Lionel, the point is, in tomorrow I will order our storage on Google Drive, and I will put up about 50 gigabyte of material that is for training purposes, with bounding boxes that already pre-calculated. So you will have a source there and have access to that you can learn how to build up your classification system. So let's say from next week you can already start with this material.
great.
Okay.
Great.
Perfect.
Okay.
Perfect.
Cool. Google Drive.
Very nice. Very nice.
Ordered the Nashua cam this week.
You ordered the mesh network?
I ordered the Nashua. I ordered the cam this week.
Oh, the camera.
Yes.
You mean that a security camera, the Fisheye from Tahua?
Yeah, the fisheye. I ordered the fisheye.
Yeah.
So I was hoping to get some training data on my own, but okay, from the Google Drive, it's also good.
Yeah, but when you can create your own material. We try to collect hand filtered, human filtered material on the Google Drive. So we have
I have a bunch of this.
Yeah,
I can share with you on the Google Drive. I've been sending it to Mike.
Yep.
Well, Mike has shared with me something on Dropbox. I'm downloading it at the moment. It's huge. It's not done yet. I got the link this morning. So
If you
maybe
need
that's
any
the
more,
same thing.
well, mine are pre-sorted, so I've cataloged them
You went
myself.
through it.
Yeah, I have it lined up as birds, planes, unknowns, and then which are mostly artifacts of light, and then I think it's meteors.
Good.
All right.
Meteors. Awesome.
Yeah, you get quite some classifications. Do you know the paper from Chris Coxwell? You probably not. I'm looking for it because Chris Coxwell was with SkyHub and he came up with the same idea about physics behavior classification.
Was it the kinematic model?
Yeah, the kinematic model, right.
Yeah, I think I have it somewhere.
Yeah, we posted in the machine learning channel. That
Okay.
you can have a look on it, what the ideas of Chris Coxwell were at the time.
Awesome. Well, if you find it, post it on some channel. Awesome.
So, a quick update on the teams. We have. Do you see? No, I didn't share my screen. Sorry. Oh dear. Hold on. Screen share. Yeah, here it is. Okay. Do you now see the teams?
Yeah.
Okay.
Yeah.
We had some little changes, and we set team leaders that are responsible for their teams, let's say, so that it is more easier to exchange information. For the GUI, it's Rebecca. For the enclosure, it's me. For the hardware and the climate control, it's Brad. For the software side, it's Christian. Christian is on several points here. It's Paul for the machine learning part. The thing is with Paul, he's not very easily accessible. He's not on every Sunday meeting. Let's say every second Sunday meeting he will show up. But you can always get in touch with him via Discord and exchange in chat. And because you are also on our Signal developer group, you can exchange there with him too. So yeah, that's for a short update here. Okay, back to so many clicks here. Okay, done. Yeah, okay. Yeah, it's a bad thing that Mike and Paul are not here today. I just want to point out that for the machine learning part, we are running now 3 paths. One is Mike's motion detection path. The second is Lionel's kinematics path. And the third is Paul's image recognition path. Image recognition, neural network, machine learning stuff. Okay.
Understood. Yeah, great.
So, Alex, as you are in this team, I have to refer you to Paul, Mike, for more details. Paul will be also on the ClickUp on the project management, where he shall, and it is already there. It's already filled up with several items. He shall fill it up with all the needs that are there, and then communicate back to you what are the next steps that shall be contributed in. So we don't want to make a wild grow of every ideas. We want to channel them somehow. We now came up with 3 ideas for the machine learning, and they're very separate from each other and very valuable for each own because they work at the end in tandem. But let's say, yeah, if someone comes up with a 4th and 5th idea, we have to discuss this. What is the value? Is this something we have? Someone shall go on and follow this.
Yeah, I got it.
I wanted to say that you better talk with Paul or Mike about it. about your
Yeah,
next step.
I have a connection with Mike this year in Friday, as far as I remember. And so I asked him about what I can do in his simple tracker repo, and he gave me some advices, and so I'm in.
Perfect. Yeah, the motion detection per se is a wide field, so he needs every hand he can get, definitely.
Yeah.
Okay. Yeah, that point. So yeah, actually with machine learning, Christian, we're done. If there's anything else, we go over to the user interface, right?
Yeah.
All right.
Maybe one suggestion. Paul brought up on the last meeting that it would be good to have several teams running different subjects as some kind of competition. He meant by that there are multiple paths to find a solution about a problem, and that splitting up the teams into subjects could help with finding the right way to do things, and that all the teams can see if they can combine all the subjects together. And I think we should give it a try, and therefore splitting it up to Mike, to Lionel, to Paul is a really good thing to do, because then we can focus on things in parallel.
Mm-hmm.
And but we can't do that with the hardware side and with the old Skycam, because there are these things are much more in serial, not in parallel. Because without any optics, without any camera, we can't get any video, and so we can just write programs and they go into nirvana because they don't match.
Yeah.
And the beauty comes in where in ML, because we can do those things in parallel. So
yeah, and we're
just
working
as
on material that's already existing. So
yeah. So yeah, we should focus on that. That we have maybe 2 more teams that take out the subject and focus on that.
Yeah, good.
Not only the performance thing. This is it's a very, very good move. I like that. And Mike was concentrating on the performance side too. So I've got some matching with there too, because you know the thing about the too small buffer of the Jetson Nano, and yeah, those things fit. And yeah, we should encourage everyone to see where we can, let's say, put up 2 more teams in ML to focus on some stuff.
Yeah, absolutely. I mean, even the motion detection field is a very wide field, and you have several algorithms and approaches that should be tested. So,
Yeah.
But Alex, yes, you are in contact with Mike, and that's the perfect place to be.
Yeah.
Yeah.
And even the idea of, we discussed it last Sunday very shortly. When a bounding box is created, is calculated, then we can also take a subset, a cropped version of that image, not only the bounding box, but let's say with a little bit of a frame around, and train a machine model on that material. Because if what else shall an identifier based on image work on? The whole aspect of the view where the noise is killing the signal. That's why my proposal was last week that we take subsets of a frame and make a pseudo video from that, so that, or give just the frames to the machine learning network. I was a little brabbling here, but I hope you get my point.
In astronomy, we call those subsets apertures, because it's just the thing around, let's say, with 10 pixels as surrounding, and to concentrate on that will reduce the consumption of the performance, because you have a reduced set of pixels which can be worked on much faster. So it's a good idea, yeah.
Yeah, that's one thing that either Paul or someone who works with Paul should follow, I think.
Yeah.
All right. Okay, let's go over to the user interface. We had a meeting this week with Rebecca, team leader of the user interface team, and we brainstormed where we want to see the user interface in the future and what purposes it should my English is bad.
Fulfill.
Fulfill. Thank you. So, Rebecca, maybe you can sum it up for the rest. You're muted.
Can you hear me?
Yes.
Yeah.
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 Okay.
Perfect.
All right. To summarize, in the kickoff meeting, we just went over, the various aspects that we're going to need in the GUI. The main thing about the GUI is that it needs to be intuitive and easy to use. Something where you don't even need to really think about how to use it. You can figure out just by looking at the interface how to use it. We're going to have basically, I want to say 3 aspects to it. There's going to be the main page with the video, and then it'll open up to show the PTZ camera also when that's activated. And there may be a few bits of data from the sensors on that page as well. And then we'll have maybe a second page, but something that you can access easily that'll have the information from the sensors as well, and the temperature of the sensor, the temperature, humidity, that sort of thing. And then we may have a third page where you can, for example, edit the video before you upload it and things like that. And we're going to have different styles for it. I think we're going to start off with a beginning landing page where it's dark. Some people do work in the dark, so they need to have very low light coming from the computer screen, and then people can go ahead and sign in, set up an account, or go straight to their pages and start working on it, using it, accessing it. And it's still a little on the beginning stages, but that's pretty much the summary to it. Branton and I were talking about how we might be setting it up so that it can be used offline. From what I understand, everything's going to be on a network, and then for people who have internet access, they can also access the APIs that are available via the internet. So Branton and I worked on an option to just go ahead and make the GUI accessible offline, but be able to access the internet, the network, and then we'll have APIs that can be disabled as needed, or enabled when they're online.
That's great work already.
So one of the key points that we already decided, Christian, please correct me if I'm wrong, is that for the user interface we will use a dedicated board running a web service and doing all this collection of information and preparing it for the user interface. Was a question?
Yeah, I think this remains to be seen where we run that. If we keep the latest idea that the Jets Nano is the graphic card to the Pi, and the Pi is the buffer to the Jets Nano, we have to decide where we will run the service. I think it's a performance issue.
Yeah, I think so too. So I would not say we should put that load onto the Nano as well.
Yeah.
So you're on the same page in saying it should be a dedicated board.
Yeah.
Oh, okay, passed. So in that case, we have to add it to the schematic.
The ever-growing list of boards.
The ever-growing list of boards, right? Okay, just making some notes.
Yeah, go ahead.
Okay. Rebecca, question. What do you think? Because
Richard, just listen to what Lionel proposed.
I don't think you can hear him.
I didn't hear him.
Yes.
Yeah.
Yes, we can.
Yeah.
Oh, I didn't hear him. Okay.
Richard, you need to start again.
Internet browser.
Ah.
Why don't we do the heavy graphical lifting in there? So a JavaScript-based application that
No,
talks to some REST API. And we just host the REST API on the Jetson or Pi. It's lightweight, and so that we keep the processing power to the stuff that we cannot do in the browser, and let the users' browsers work for us.
No, that won't be possible. Imagine that you've set up a station and you put it on the top of a mountain. Do you want to sit next to it 24 hours a day and use a laptop at it? No, you want to have remote access to the station. And the web front end is just for showing things and operating. You do not operate things actively, because you get on the one hand you get your view from the old Skycam, and if there is an event, then PTZ is added to that view. You've got some sensor readings out there, and this is the basically stuff and almost it. And in the second place, there comes the possibility to, let's say, invert your video to get a better contrast or something like that. But this is not done on the on the hardware and at the station. It's just the web view.
Okay, good. Thanks.
But we have to set up some kind of service server, let's say, some kind of VNC, or you can use secure shell to connect with external to it and get the display to your computer. And therefore, it's good to have, let's say, a website who does that, because it's intuitive and it's very easy to use. And you do not get distracted by anything else.
So the thing is that there will be different views. One view is, let's say, only the event view, live view or historic data. And then you have certainly a maintenance view where you can check how is your system working, is the SSD not running full, etc.
Well, I was imagining that these views would be each of them would be what we call a one-page application. So a web page that displays JavaScript, and the JavaScript then goes and retrieves the data from the station via APIs.
Yeah, but more Django one, not that depends. If JavaScript is fast enough.
The APIs, they run in Django, but the retrieval and display of the data to the end user
is done by Python. So Django would be a good choice.
Then Python builds the HTML page. I was thinking that the JavaScript builds the HTML.
Not necessarily, because the sensors are driven are Python driven. The cameras are, so putting up Java into it may reduce performance.
And then also another advantage is that it's portable to different platforms, because now as I understand it, the end users, they're gonna have to install some framework apart from the application. They have an installer.
No, they do not
No?
need that because they just
don't
have
need
to
it?
connect to the site. They just have to open up their browser, let's say Firefox, go to the,
Okay.
let's say, local dot whatever port we choose,
Okay.
and have the screen because it's running on the Nano or on the Jetson, on the Pi.
Okay. Okay. Well. Okay. Thanks. Thank you.
Yeah, I think it's a good idea to have a dedicated board for that task.
Yeah.
And that would even make it easier for developers to work with. Rebecca, ever experienced a web service on a Pi, for example? Okay.
You can take a look at Stellar Mate OS. They make use of VNC, and you can control the complete system with that by just connecting to its IP address.
Okay. So if Rebecca is for the front end, who does the back end? Rebecca, is there one in your team? Is Brandon someone who does the back end? You're muted.
Okay. Can you hear me?
Yes.
Yeah.
Okay. Branson right now is working on that. We were actually thinking of creating like a virtual machine, you know, a VM, and then that way everybody could have the same setup and make it much more easier to use rather than everyone separately installing whatever it is they need to have the site working. You know, pulling all the files and everything from GitHub, that kind of thing. We thought it would just be easier if they had a VM. Can you hear me?
Yes.
Yeah.
Okay. And so Branton is working on that, you know, something that can be used with Mac, Linux, Windows, everything.
Okay.
So yeah, he's the back end guy. Mm-hmm.
Perfect. Perfect match.
Mm-hmm.
One question, okay. Rebecca. Your paper has now many points, and it even increases over time. What do you think of making a kind of graphical overview in a sense where you see what
some kind of mind map?
Yeah, kind of a mind map where you see what are the sources of information that are now brought over via to the user interface, so that we have that also you yourself kind of an overview of that. What do you think?
That sounds like a good idea. Very good idea.
Would you do it?
Oh yeah, sure, absolutely, okay. Yes.
Perfect. Okay, great, good stuff. Yeah, it especially gives every one of us the overview if there's something missing out or maybe something too much. You know, this visuals are at least for me, it's important to have it visual.
And it keeps it organized, and that's important with something this extensive.
Yeah, it gives at least an idea if there's something missing or something too much, kind of, yeah. And how the things interact or hang in each other. The video playback and overlay is still a topic that is unsolved right now. Do you have any idea if there's anyone who can help you in this, or shall we wait until someone shows up and says, okay, I'm a specialist in video overlaying?
That I don't know. We were able to get it to work in PyQt5, but we haven't worked on the Django to see if it works in that. So we can try to see if it works in that.
Okay. Okay. Yeah, that were my points. Any other points from the user interface?
Did you try to it only with PyQt5 or with PyQt6 too?
Originally, I just tried PyQt5. That was the first thing that was brought up to me. So that was the first thing I tried when I first joined up. So just the PyQt5, but I would think it would work in PyQt6. And then we would need to, we were deciding between PyQt5 and Django, and so we were going more with Django. And now we got to see if we can get it to work in Django. And if we can, then we don't even really need to see if someone else can help us with that. It might be as simple as just trying it, but I don't know yet.
Yeah. Okay.
All right, perfect. Thank you. So, we'll go. Any questions up to now? Otherwise, we step over to the climate control part. Alex, any questions?
No.
All right. Yeah, there's one point. Sorry, I almost forgot that point. There are in your paper, Rebecca. There are mentioned data sources outside of Sky360. Let's say weather data, ADS-B data, meteorologic data, what have you. Yannick, my question to you. Would you be able to help Rebecca in creating the interfaces to those data sets, to those external data sets, like weather data?
Yes, I posted a link to the weather repository in the GUI channel.
Yep.
And Rebecca saw that already, so but if she has any questions regarding that, I can help, of course. No problem.
All right, so the thing is, my question is to you, Yannick, whether you can take over that part of creating the interfaces to these weather sources.
Actually, I'm not quite sure what you mean with interface. So it's all done with an API. So you just send a request for the data that you want to have, and this is all already in a function that I coded and uploaded on the repository. So if it is related to the visualization of the weather data, then this is something that okay. Yeah, if I think I would need to get basically a sketch of the GUI interface and a placeholder basically where the weather data should be positioned, and so I have a sense of how much space I have to actually show the weather data. And so for example, I guess when you have an observation, you only want to know, for example, the air temperature or the wind speed, and that could be displayed in just the numbers. But I don't know if you would be interested in having some kind of a plot of any kind of weather data, if it's wind speed or
you mean a two-dimensional
temperature,
plot?
or for example, like a time series plot, or actually something that I was thinking of what could be interesting, which is usually not in any of the APIs, is basically a check if there was a temperature inversion or something like that. Because that is, well, in the UFO community, it seems that I've read that temperature inversions can have some optical effects that could be interesting to rule out. For example, if you have an observation and you can basically definitely state, okay, there was nothing like a temperature inversion, because we just know it from the data that was pulled from this API or something like that.
So, and temperature inversion is delta T over time, or how can I?
No, temperature inversion is a temperature increase with height, and so
the height
usually you
layers.
have a
Okay.
decreasing temperature with height, and a temperature inversion would mean an increasing temperature with height.
Got it.
Looking at the potential temperature, and so
Some kind of thermic.
yeah, it happens typically when at night, for example, when the ground cools off quickly, then you usually have colder temperature layers below warmer temperature layers.
Yeah.
And I've read in some UFO related documents that there were some claims that it can have some optical effects that can look like UFOs. I never saw that in
Sundogs.
I've never read that in an actual scientific paper, but I can do some research on that too, if you're interested in that, because for my actual day work, it was never interesting to look at any kind of these optical, very rare effects in the atmosphere. So
they have to go along with high humidity there, because then you get an optical effect.
Yeah, that makes sense.
When the humidity is falling down, let's say shortly before sunset, you get that optical effect with telescopes, because it gets very wet, and this increases the seeing, the disturbance from the atmosphere. And this seeing, makes, it shifts the position of an object. The refraction goes up, and you can't determine its position or its lightness, its photometrics. And therefore, it's nice to see whether you've got such an inversion or not. I've got another question about another topic. I would like to see some kind of cloud coverage.
Yeah, that's no problem. That's what we have already in the repository.
Is it possible to get some kind of prediction for, let's say, the next 3 hours?
Yes, I think that's already included in what we have. So we have a forecast, and I'm relatively sure that the forecast includes cloud cover.
How accurate is it?
Good question. I can work on some kind of a test, let's say, that checks how good the forecast is.
Okay, because let's say you've got some ground stuff, like not that high mountains in shape of, let's say, a half moon, some kind of you've got agriculture stuff, like newly prepared acres, newly prepared fields. They give up a high amount of humidity over time and don't cool very much. No, they heat up not that good as, let's say, plains, and all this stuff changes how clouds are moving. And you've got thermical problems to that, and this alters how the clouds behave. And the cloud coverage that, let's say, you can see at wetterzentrale.de or with Kachelmann Wetter, they have problems predicting that.
Yeah, I think it also depends on the time frame. So do you want to have that for the next day, or do you want to have that for the next 3 days, how far do you look into the future, right? So what would be
they even have
relevant
those
for you?
problems with 3 hours.
Okay, and what time frame would be interesting to you?
3 to 12 hours.
Christian,
3
may
to 12
I
hours,
question
okay.
the relevance? Why is that for?
If you have a cloud coverage prediction, it changes the contrast in the detection of an object.
All right.
But is it not sufficient to have the actual cloud coverage during the observation in hindsight?
Yeah.
Or is that not?
No, not really. The prediction is nice to have because then you can plan. Let's say, okay, I've got some time in this evening, and I want to spend some time with my station. And if you know, okay, the cloud coverage will increase or is already there, then you can say, okay, maybe I do not have to have such high expectations about the next 3 hours or the next 12 hours to capture anything not interesting. So it helps you plan what you want to do with your station.
Okay.
Yeah, I can certainly work on that and test maybe the API that we have already. And Rebecca also pointed to another API that we could also integrate. So I can check what I can find and test a little bit how accurate the cloud cover forecast is actually in that time frame. So yeah.
Does I think it's METAR data, METAR for aviation, for airports. Does that include something with cloud cover?
Not as good as the two mentioned services. They provide such information, but it's
only for airports.
Let's say the accuracy is about 60% if they both say the same. And in case that they don't agree to each other, they about to 150 kilometers away of it, and I'm here about 50 kilometers away from the next airport, and I get those information because I need it for my astronomical observations. But I recognize that they just reach an accuracy of 60% if they say the same. If they differ, the accuracy is for the next 3 hours. It's bogus.
Hey, Yannick, one question. That every data you retrieve via the API, this is, I assume, is not live data. It has a timestamp in the past, right?
Yeah, you can ask for or request historical data, and it goes until the latest time step that you can get from the last hour, I think, usually.
That's what
Depends.
I mean.
It could depend a little bit where for which location you ask for the data. So, but usually it should be up to the latest hour, let's say.
But that means
because
it has a timestamp.
It has a timestamp, yes, of course.
Even if it's the recent one, it has a timestamp that is in the past.
Yes, I think so.
So
you can also ask for the so-called current weather conditions, which is usually for the latest full hour, let's say.
Okay. If you combine this with the forecast of the next hour, would that fit? Let's say if you have a timestamp of the last hour, 1 hour ago, but you also have the forecast, let's say for the next 3 hours, you can say, okay, now it should be, with high probability, look like that. Is this feasible? Or?
Yeah, I can look at that. Yeah, I think it's feasible to at least check it and see.
By this, you could create a real life. Even if it's not measured, it's estimated. But I think if it's only 1 hour in the past, then the weather doesn't change that quickly. If you're not in the Netherlands.
Yeah, right. Yeah. So I think you can You can rely on the current, so-called current weather conditions.
Which is 1 hour on age at last.
Yeah, usually it's the latest full hour time step. So, and usually the data that you get are hourly averages. So you can go for smaller time steps in some cases, but not with these, as far as I know, with these APIs that give you a global coverage.
Mm-hmm.
So of course, when I go to specific APIs from NOAA or from the German Weather Service, I can get time steps of 10 minutes and so on. But
yeah, it's only for the US. It doesn't help.
Only for the US or only for Germany, and it's a big puzzle basically to get that kind of stuff for
of course.
Yeah. So I can look if it makes sense to combine the latest weather data with the forecast.
Okay.
Yeah.
Perfect. Is there also information like humidity and dew point and let's say all forms of snowfall or rain?
It does include rainfall. It does include snowfall. It even does include what I find interesting. It even does include the moon phase.
Okay.
Which could be interesting, and it also does include for every location the sunrise and the sunset times.
Okay.
And that could be quite interesting, I think, because you directly see, when you have an observation, let's say it's at night, you can directly see, the moon phase was 1 or a half or whatever. So you have an estimation of how much diffuse light should be there in the image and so on. I think it would be handy.
Background illumination of the sky.
Yeah, exactly.
I throw just a stupid idea into the round. From my point of view, I'm having my station out there since 2 years. And what I can see is that, of course, when it is raining, you create a lot of events, which doesn't make sense because you have this droplets penetrating your little domes. It's good, tick. There's too much of events, let's say. Why not use weather forecast or the weather information to tell the tracker to work or not to work? You know what I mean, Christian?
Yeah, we could use some kind of knock sensor to collect the raindrops and say, okay, let's reduce the sensitivity because, or set out the sensitivity because it's raining.
You could do that with a camera.
Help. No, it could be fitted to the dome.
That's another sensor and another thing someone has to buy. We get a lot of that, and it's getting expensive and complicated. So if we could have the camera look up and say, "I'm wet,"
they are not very expensive.
Are there acoustic sensors on
acoustics
embedded already?
Yes.
No.
Yes.
Yes.
Geophone, for example.
I'm thinking like a acoustic knock sensor, like you'd have in like an engine, like in a car that detects a knock event. Like if you could recognize what rain sounds like, you could adjust the gain. I was referring to that.
Oh, that's a nice one.
Okay.
I was, I know where to get some of them. Adafruit provide them, and they're very, very easy to use, and I don't think they cost very much, below $10. We have to look. I was interested in them 2 years ago. I don't know what they are up to now, but with Adafruit you can get them, and they're very, very easily to get and to read out.
So what happens when one of those sensors gets stuck, and then it just takes your machine offline?
We have to prevent that.
I'm saying don't use a mechanical sensor for that. I mean, if there is a way you could, I mean, we have thousands and thousands and thousands of videos of rain. Surely we could train the machine to see rain droplets on its lens and say, okay, until I am dry.
We don't take it offline. We just raise a flag and say, okay, it's raining.
Exactly. But the machine could figure that out for itself, could it not?
Should be possible.
I'm just trying to avoid more sensors and boards. I really am.
But I think the sound, the visual, I have videos where a bird put his poop on my dome. And it would look like if it was raining, it were some droplets of something falling on the dome. But actually,
well, we don't want a record of it, so.
Pardon me?
We don't want a record of that. It's not interesting to us. So if it misinterprets rain,
it just covered 50% of the view. The rest of the 50% is still active. Can still detect something.
Yeah, it's still. You can still see things even though it's raining. I think there's an example video of that.
When it's really raining, it's hard because with a bird poop, normally you get it only once. But raining gets a permanent penetration of the dome. So in that case, the sound idea, I think, makes more sense than just an optical thing. The optical thing could be an illusion of a bird poop that happens just one. Yeah, okay. It had to be over several frames, new bird poop showing up, then it is rain. Who was that? Okay, something else.
Quel papier? Tu pas là-dedans?
Hello?
Now Lionel is talking to his kids, I assume. So one question is to you, Yannick, because we fathom also a kind of, let's say, this user interface is first and foremost.
D'accord, vas-y.
Lionel, we can hear you.
Can you mute yourself?
Sorry.
No
Sorry.
worries.
Okay, I'm gonna hang up and listen to the recording. It's getting difficult for me. So
Okay.
Good night, guys.
Good. Bye.
Bye.
So we fathom the user interface as most important for the user who built his station, because that's why he or she does it, because he wants to have that one in sky awareness around him, and of course they want to capture UAPs. But I think it's also important to see not only your station, but your station records, but also have a global view. Kind of a map view where you see other stations and you see maybe there's an event or historic events listed up. Or maybe we can even then in the future triangulate from station to station whether something moves between the stations. In that case, if we have a two-dimensional map view of Earth, I think, and that was my question, those APIs also provide a two-dimensional plot to be as a layer brought over that maps, right?
Good question. So currently in my current implementation, it's not like that. So you can ask for weather data for a latitude and longitude, and then you get back the weather data. Of course, you can basically with that you can make a grid if you want, and you request data for every degree or whatever on the map, and then you can visualize what you get back on a map if you want. But if we want to do that, we can work on that, and probably there is an API that can give you back the data for a specific region as gridded data already, I presume. But I haven't worked on that, so I can check if I can find something like that. The point is, if we do that with our current implementation and ask for like a weather grid, a global weather grid, that's very costly, very fast.
Okay.
So I would say. So we have, I think, 1,000 requests for free currently per day.
Per day.
And so for every point, you would need to make a request.
Mm-hmm.
So when you make a request for 1,000 points, you already have your 1,000 requests.
We can make a lot of requests if we tie it to our videos.
If we have the money, yes, we can. No
I
problem.
would have made 15,000 in the last 30 days. So that if you tied it to an event recording, I recorded that many in the last 30 days.
Okay.
As is, we'll get better in our future setup. But
so what we can do to increase the number of our requests is, for example, that we just collect free keys, basically. So every email address that we type in the website of Visual Crossing, that's the API provider.
Mm-hmm.
We get another 1,000 requests for free. So if we have people donating and basically just going to the website and getting an API key, we can collect the keys, and for every key we have another 1,000 requests for free.
If every user with his station creates such an account in order to get the weather data? So it's
right. That would be
user-based.
possible.
So everyone has his own 1,000 requests per day.
Yeah, that would be possible.
And I'm guessing we wouldn't make this automatic. The user would be, you would have some event that you recorded that you're now interested in, pairing it with other things like weather. You would send a request at that point. You wouldn't automatically gather this data for every event you recorded, right?
Right.
If it's historic, you can go back and tell it what time frame to look at. You can just pick that one batch, one request, right?
Right. That's how I would do it for observations and eventually for forecasts. So I'm also thinking about weather alerts, for example. So with this API, we can get weather alerts, for example, hail or
that would be
thunderstorm.
nice.
That would be nice.
Yeah.
That would be very nice.
Yeah.
Because I'm thinking about making a hail blanket for mine somehow, because unlike the nice Alps people that never have to worry about this, we have
hail.
Softball size hail.
Yeah.
Tennis ball.
Yeah, we already have that implemented, this weather alert thing. So
that would be good.
Yeah.
Was it 1,000 at whole or 1,000 a day?
A day.
It was 1,000 requests per day.
Wow, that is a lot.
Well, depends. If you have 1,000 requests per day for every user, I would think that should be enough. Yeah.
Yeah, it's 1,440 minutes is 1 day, so it is almost 1.5 minutes.
Very accurate.
Yeah, but we don't get the time resolution for that.
You get 1,000 times the same answer.
1,000 a day is a lot.
Yeah.
Okay, it was just a stupid question. In the future.
So when do we get it?
You want to have it for your astronomy. I know it.
Yeah, synergy effects.
Yeah, he posted it in GUI, his repo. You can already use it.
Yeah, you can already use the function in the repository. I posted it in the GUI channel.
Yeah.
It's not too long ago. So it's the weather module. So but I can send you the link right now if you want.
Yeah. take your time. It is. I'm focused on getting the old Skycam to work, so I'm occupied with that, and I think this is the most important part. So we talk about that later.
All right.
Christian got a gadget prohibition, so no, he's not allowed for new gadgets right now.
Yeah.
Consumes. Okay. Anything else along that line with the user interface? Any ideas? Any things you want to discuss? Otherwise, we jump over to climate control, right? Okay. So the climate control. We are at the point where we shall talk about how the test setup shall look like, and who is going to set up the test setup. Who set up the test setup? Okay. I would like to head over to Brad and let him explain the test setup and how we shall proceed.
I don't have a lot prepared. Let me see. I'll share my screen without running out of memory. It's almost time for a new laptop. Okay, see that?
Yep.
Okay.
Yep.
So I took Richard's model of the loop and I sliced it up into some printable parts. Working on that now. So yeah, this is a problem, Richard, with supports. Oh, did I lose somebody?
No.
Okay. Sorry, my Discord screws up when I do this. So like you can see, this it takes 23 hours to do this, and most of that is from supports. So I had to slice this up so I could print as few of these pieces as possible, because there's no way to print this without this collapsing and ruining like 12 hours of work. So I think I got that worked out, and I think I can probably produce one loop in about a week if nothing screws up, devoting 3 machines to it. And that's also printing the scaffolding, which I have. Let me go back over here, minimize this.
Did you try to turn the parts about 45 degrees so it reduces support structure?
Well,
I had some very.
They're standing upright on the print board.
45 degrees. 45 degrees.
Yeah, but just putting it on, let's say, the outer edge helps reducing the support structure, because with an angle of 45 degrees, the overhanging parts are getting reduced. I had a very, very good experience with that with my other project, the Sun Glider, and we were printing the whole structure laid over to the side of 45 degrees, and it reduced almost 78% of the support structure.
Yeah, but in this case, the elements are 90 degrees setting upright, let's say. So you print vertically up. And the only supports right now is in the openings for the peltiers. Wow, Brad, this is... do you see the same? It's coming and going, Brad's stream?
Yeah, but this needs a lot of...
Okay.
Hey guys, I have to move on. So see you next week, maybe.
So
see in 2 weeks, I guess.
Yes.
All right.
See you. See you. Bye bye.
Bye bye.
Thanks.
Yeah. Welcome.
So I don't know what you with your stream. It comes and goes.
Yeah, it doesn't like itself. Full is quit.
What I want to point out is the question. Who is going to build it, the test setup? Who wants to test it? Who wants to be involved? And how shall we do? Now you propose the real thing, the tube as it is designed. But there's also a thing that you can discuss whether we use just a PVC pipe, a rectangular PVC pipe, because it's just for testing.
No, I would build this. I mean, I'll build it and mail it to everybody. It's not a big deal.
Okay.
That would be excellent.
I mean, I was even going to go as far as to, it's going to require scaffolding support underneath it because you've got the, I don't want to call it a nipple. That's inappropriate. What was this, Richard? A dripper? This thing?
The dripper.
Yeah, it sticks down below the thing, so it can't sit on its base. So it has to be held up in the air, and you're going to be putting, power supply and everything else that is going to heat up in the box, and then putting the lid on top. So you got to have some sort of support. So I have designed earlier this year that it uses metal conduit, that EMT tubing, electrical conduit, super easy to buy and cut. I was going to build kits and just send it to George and Boyan if they wanted it. I mean, I don't know if you can cut pipe yourself, what your setup is, or plywood.
Yeah, I can certainly do some fabrication to take some load off of you.
I build these
currently
time,
just
so it's
sourcing the different.
And you're going to need like a sheet of plywood. That's all it is to it, to give it a flat surface to mate to. And then, of course, it's going to have to be taped. Those seams are going to have to be taped because even if we get it 100% straight, it's still going to be kind of leaky. So it's not going to look like much. Mm-hmm. And I can't guarantee that it's not going to be like 9 different colors because I'm going to use all of my waste spools up on it if I can. The only thing I'm hesitant in printing right now is the Peltier mounting sections because we don't have the heat sinks 100% sourced. So I don't have a virtual model of exactly how that's going to mount.
But that's not an issue, Brad, because there we have the frame for the Peltier frame, the frame that holds the heat sinks and the Peltiers in place. We can exchange because the frames are screwed onto the tube. So if we decide to take different heat sinks, we just exchange the frame and you unscrew it and take other ones.
Well, yeah, but you already have the holes for those preset in these. So if those holes move, that kind of changes things. So I was just going to double check that before we got too far. I mean, that is still a serious time investment right there. Yeah, so I was going to at least have some kind of heat sink ironed out. And looking at Alpha Novatech, we don't have a lot of physical space. We can't put big heat sinks there. So we're probably going to have to live with the fact that when it's 40 degrees outside, those heat sinks could get very hot. Very hot. Because we're having to use smaller ones, and we're having to take a higher heat load. So we'll see.
I saw heat sinks for the exterior side. They were recommended, let's say, by heatsinksonline.com, where they say for the outside they recommend smaller fins. So not that long fins, not that extension of a fin. So they have a kind of a grid that is 50 millimeter height of the fins by 80.
Yeah, you don't gain anything really when you add height to it. I mean, I think the general rule of thumb is if you can double the size of the base, you double the heat absorbing capacity. Yeah. If you double the height, you only get it by like 1.4 times. Yeah. So it's always better to have a bigger base. We don't have a bigger base. We have height. We can make it as high as we want because it's going to stick out the side. But it doesn't get us anywhere. So we're going to have to use, and also we're bound by what they make and what we can get that's not stupid expensive. So that's going to be about a 60 by 60 by 40 heatsink with the fins or pins, whichever route we want to go, would be dents on the outside. They'd be bar spaced on the inside. Almost still streaming.
This is good source. This is good source for heatsink. Cheap heatsinks.
Yeah. I I like Alpha and Novatech because they actually have the performance curves comparing every single heat sink in the individual family, so you can actually see the pressure drop. You can calculate, how much heat can be transferred just based on those curves. So it's really handy to use the Alpha Novatech website. That plus they're pretty cheap. I haven't checked shipping yet. That might bite us in the ass later because I'm sure they're going to get us on shipping. But their prices for at least the heat sinks themselves are not too terrible, and they got a lot. So,
what if we take a 80 by 80 by 15 heatsink for the outside?
If it'll fit.
Fit? Yeah, they do. That's what I designed for, the 80 by 80 by 15. I mean, you can go to higher if you want to. But 80 by 80 is something you find rather often.
Yeah, you don't. And you can, when you start going into like rectangular form factors, well, then you got it asymmetrically positioned on your Peltier. So one half of your heat sink is just hanging off here in space. The other half is absorbing the heat. So you have this. It'd be better if it was centered, in my opinion. But we don't have a lot of room laterally to put a big rectangular sink, side by side.
Yeah, vertical. Yeah.
So, and also when you go over to those rectangular ones, I found that they usually like to go like 100 millimeters. Well, we don't have that. So it's pretty much going to be a square something, and we'll test it and see.
Yeah. Hey, we have to start somewhere. Brett, you have to decide somewhen on a heatsink that we all test.
Well, I think I don't know, George. You saw the ones I saw or was thinking of for the interior side. I had one picked out for the exterior, but can't find it.
Per their website, it seemed like almost everything was out of stock. That I looked at least last night.
I didn't see that last time.
Maybe I was looking. That might have been. I was trying to find a good heatsink for the external. Maybe that's why. There are a lot of heatsink suppliers, though, other than Alpha Novatech. So if they do have a stock issue, there certainly should be another place to source from.
Yeah, it's just handy because if you can get something, the performance. A lot of places don't list the technical information like this. Is right up front. It's just convenient to use the site.
Yeah, definitely.
Really, we can find something similar elsewhere. So the ones I was thinking of for the LPD 60 for the internal ones, those are in stock.
Okay, good.
Can you share your screen?
In America, at least. Let me close Fusion. Hold on, I have too many Fusion things open. Did that work?
You shared and unshared.
No, I didn't. I shared. I only
share
shared.
The screen, not the window.
How about that?
Loading. Yeah, it is there.
Yeah, it's work.
Can you show the product? This is your shopping cart.
Yeah, it's basically that.
Ah, yeah. 60 by 60? Looks square.
Mm-hmm.
Okay.
With pin spacing as far as I could get it.
What about do we really care that much about the heat sinks on the outside? Shouldn't we much more care about the IP67 fans and what sizes they are available?
Yeah. I mean, the heatsink is important. Don't get me wrong, but if we're limited on size and what we can, I mean, how much heatsink we can put there, we do have to rely more on the fans. I have found some that are about 80 millimeters, I think, but they were line voltage. They'd be 120 volts here. They wouldn't run off the.
Wow. Mm-hmm.
Yeah, and then I found a bunch of others that were 24 volts, which I guess is not too big of a problem. We could do a buck converter, but I was trying to keep it in the 12 volt family for simplicity. But yeah, I do have an 80 millimeter fan here that's decent. I think I got like almost 5 CFM directly at the fan blades, which that's a decent size draw, I think. But it's IP67, and I think if we have it tucked under the thing enough and out of the moisture, out of direct water spray, I think that it would survive. I don't know if I would trust this thing just as it mounted on the outside of something and completely exposed to the elements. I don't know if I would trust it.
Yeah, but it's certainly not directly under rain. It's more humidity and dust protection.
And it was kind of expensive too from Amazon. I think I paid $25 for this little thing, and then you multiply by 4. Yeah,
right.
And therein lies the problem with having an array of things. You increase your cost by a multiple of however many things you have, and you have 4.
Yeah.
So.
Right. But I think the availability of an IP67 fan defines the size of the heatsink.
Oh, I think the heatsink is going to be that size. I don't think I think it's going to be the maximum size we can fit.
With heatsinks, it's the bigger the better, right?
Yeah, and in our case, yeah, it absolutely has to be the biggest.
Yeah,
we can fit in that real estate.
And I made the frame for the tube that you showed before for an 80 by 80 millimeter heatsink. Because I just took the Noctua, not IP67 80 by 80 fans on it. So if you find an IP67 fan of 80 millimeters, then perfect.
I've got one. It's just not great. I mean, I'm sure there's better out there, but.
Okay, so we're still scouting for IP67 fans of 80 by 80 millimeters.
I'd like to see alternatives to what I have found.
Yeah, but the parameters are IP67 and 80 by 80 millimeters and 12 volts, kind of.
If possible.
Okay.
And, we are designing this for the extremes. I mean, we're thinking of this is going to be the hottest day. It's having to deal with the most strain. I mean, a lot of the times, the Boyan's controller is going to take care of a lot of this, hopefully. I mean, it's going to keep us from overheating. But we're trying to dissipate that 146 watts of heat on a very bad day for the.
All right then.
Can I go back with a question about you said that the base plate should be as low in height as possible, and the radiators on top should be as long as possible. What's behind this?
That's not quite what was said. It was just in terms of sizing a heatsink, it's making a bigger base is better than making it higher. It's just you get more heat absorption from the X and Y axis versus the Z axis.
More mass.
Yeah.
Okay. So thicker base is better.
Yeah.
Yeah.
And how much should be? And okay, this depends on what height you have got available, and the grid part is not that important.
Yeah, and then more about the density of how many fins we could pack in and how much air we can move through them.
Okay. Yeah. No, I get it. Yeah. Okay. This makes sense. Yeah.
Okay.
So it's basically increasing the emitting surface.
Yeah. Oh, we got Boyan talking on the phone.
Boyan?
Yeah.
Boyan, can you hear me? Yeah, okay, he doesn't hear us. Okay.
There was a paper
I'd like to mute him, but yeah, I can mute him. So is he now muted for you too?
Nope.
Okay.
Nope.
So it's just an individual muting. Okay.
There he is.
There he is.
Yeah.
So we have the topic of the tube, 3D print. We're going for this, right?
Yep.
I think Boyan makes a setup. He at least has one person has to make the full setup with electronics. You're gonna make a setup, Brad. And the question is, George, are you going to build a setup? Okay.
Yeah.
Perfect. So, as far as I understood, you, George, and Boyan, you cannot 3D print. So Brad has to 3D print for you, right? Okay.
Are you talking to me?
Yeah.
Huh?
We are talking about the test setup for the climate control. And
Something. My connection is dropping out. I don't know why.
okay. So Brad is going to 3D print 3 setups, right?
Yeah.
Okay. Oh, there's.
It'll take a while.
Hello.
Hi, Brandon.
Hello.
How are you?
Thank you. We're right in the middle of climate control discussion. We had the user interface discussion before, but it's already recorded. You can view it later afterwards.
Okay, thanks.
Yeah, we were talking with Rebecca about topics about user interface, and I'd say either you catch up with her or just view our recorded video. And
I will.
It's published tomorrow, all right? Okay.
Thank you.
So coming back, yeah, Brad, go ahead.
There's probably one thing, Boyan, when I talked about, or is he still on? Yeah, he's still on. Yesterday, is how to control it, and I was thinking he was going to go with a TI or a Arduino board, but he's just putting it on the Nano, which is, I mean, we can do it. It's already there. My only concern was like, under extreme circumstances, there will be a point, no matter how well designed this system is and how well it performs, if it gets too hot, we have to shut the main system down. And that is not likely, but if someone screws up their installation and sticks it right to an asphalt roof, or they put it in the middle of Australia, there's really not much we are going to be able to do about it. It's going to exceed that, and if we assume that the inside is going to run about 20 degrees above ambient, you can reach the shutdown point or the throttle point of a Jetson pretty quick, not to mention some of the other components that are in the box. So if you shut the system down in cell preservation mode, you've now shut down the climate control system. If it was completely independent, you could shut it down and not care. You could put it into a storage mode. So if I wanted to take my station offline, but I didn't want it to deal with humidity, I could leave the climate control system running. The station was sitting idle. So there's some advantage to having the control system of the climate control system, kind of redundant to say, but having those two systems completely independent of one another.
Yeah.
I guess it comes down to
I think we agreed on that already, and wasn't the decision that we keep it separated?
That was kind of the back of the envelope. I mean, when we were just kind of spitballing this. But, I mean, Boyan brought up the point, we already have the Nano, so why not use it? So I guess we're discussing the same thing again, but, I mean, do Do we want to keep it separate? Do we want to try to use the nano? I mean, it's just a cost benefit.
I think it makes life for Bojan much more easier if he has a board dedicated to that task.
And the nano is already occupied pretty much.
And this is not very software intensive stuff running there.
No.
On this dedicated board.
Mm-mm. We can use Jetson. Jetson has IOP.
Now, Bojan, the question is now: do we use the master Jetson, or do you use a dedicated board for climate control? And Brad's point was that if the master board has to be shut down because of heat issues when the thing stands in the desert, for example, the climate control part should not be shut off. It should still be in control. And that's why his proposal was to have a dedicated board. But that board doesn't not necessarily have to be a nano. It can be one of your ESP32s.
A little Arduino will do the job.
Yeah?
No big deal.
Yeah.
Nothing special about it.
Okay.
Yeah, super cheap. Super cheap.
Yeah.
Okay, so that's settled.
Okay.
And nothing.
Arduino, we go. And the controller itself, I mean the drivers for the power you need. Peltier power, for example. Does the
Arduino... I didn't. I'm sorry.
Can you give us an idea of what you need on electronics for the climate control?
Electronics, so a microcontroller, yes. Mm-hmm. Then you need something. You need sensors, mm-hmm. something to have some kind of closed loop. Mm-hmm. Closed loop. So speaking about temperature, you know.
Yeah.
And maybe another
driver. Huh?
Maybe another Teensy would do because it has plenty of interrupts if you compare it with Arduino.
No, I don't think we need to use interrupt. Mm-mm.
Okay.
No.
So just in the main event loop.
Yes. So this microcontroller had to have information about humidity and which is we using this DHT 2021 and or 11 whatever, and then we need to have sensors on a heat sinks too.
Yeah. And if we're trying to measure,
like I said, that's stupid. I can't rely on Amazon to order parts because you never know what you get. Unbelievable. Now I need to find out something else, you know. So.
Okay.
Yeah.
We're talking about sensors.
Sensors, yeah.
Mm-hmm. If the logic of the control system is needing to calculate DT. We'll have to measure that independently on each individual Peltier and control them each individually. Mm-hmm. And you've got
maybe between two Peltiers, maybe sensor on a heat sink between two Peltiers. You know what I'm saying?
Are you saying use one heat sink but two Peltiers?
Yeah. 2 Peltiers. We need to go with 2 Peltiers because we have only 12 volts power supply. With 12 volts, you cannot get maximum from one element. You know?
Oh yeah, we're on 4 Peltiers.
So yeah, but I'm gonna test in parallel and to controlling the current, you know. So we can have with smaller, because I put in a parallel, we can have. From 12 volts, we can have what we got, you know, we can have enough cooling or heating, you know. You know what I'm saying?
Kind of. So that would be about half of the total setup. So we've got 4 Peltiers arrayed in that tube, right? We've got a left side and a right side, and we've got a front and a back. The problem I see is that we've divided this 146 watts by 4, right? And it comes out to what, 42 or whatever. My math is bad.
Yep.
Doesn't matter. That heat dissipation is not spread evenly among the Peltiers.
Right.
It doesn't really matter left or right, but the front and back modules. So the front ones take more heat than the back ones, and then you can kind of compound this problem because you're putting your 2 independent heat sinks on the outside, which both radiate heat towards each other. So really, every Peltier will influence every other Peltier, and they won't be absorbing an even distribution of the heat energy. So this is why I'm thinking the 4 Peltier setup is complicated, because if we're trying to tweak a control program, the logic of a control program to maximize this the efficiency of the DT, actually try to keep the DT pretty low, you've kind of got a bunch of moving parts there.
It gets differential.
If you had just a dedicated left and a right Peltier, 2 of them, and one big heatsink covering it, you would have a lot less sensors. You would have a lot less to juggle in terms of figuring out how to optimize it. The only drawback is your Peltiers would probably be 24 volts, and they would be expensive.
Yeah, but this is an additional problem. Then we need an additional power supply.
We're going to need a big power supply, yeah.
I mean, special power supply for Peltier element.
Boya, excuse me. Who wanted to say something? Okay.
I'm sorry?
No. Would it make sense if the logic is on a microcontroller? Wouldn't it make sense to have a voltage provider driver board that you can control with the Arduino to say deliver please? You have 6 channels and deliver this, that, there.
Yes. Because you, like I said, you need to have constant current driver, So we're not gonna do pulse width modulation. This is not so big stuff for a microcontroller to achieve,
Mm-hmm.
Maybe good idea for every Peltier has own driver. I don't know about that. I need to test. I mean, this is no big deal, but I need to test how much I can have from 12 volts power supply, how much I can have pulse delta T.
Yeah.
So this is for me is a starting point, and then after that, we can do whatever we do.
So in my mind, I was thinking something like this. It's 12 volt, 20 amp.
Mean wheel, or this is like a $30. Who making it?
I pulled this off of my dead printer, so some Chinese.
Mean wheel, something like that.
Okay.
The problem is the spare parts from the printers are not very stable when it comes to providing higher amps. They can burn up easily.
Mm-hmm.
But I was thinking this something this form factor, if we can find it in the quality part that's not insanely expensive, and we have a reasonable chance of having it survive outside. There's also that. Because, I mean, this has a fan, this has to dissipate its own heat. It can't get too hot. I don't know what the thermal performance is on this thing, or it would just completely conk out. But we haven't really even designed an enclosure for the power supply for this thing.
Yeah, so the question was still whether we use the PSU that's in the inside.
You can't use it if you're going to have it independent. Because if the PSU shuts down, then... Well, I guess the PSU doesn't have to shut down necessarily, does it?
Why should it shut down? I mean, it delivers 12 volt and 15 amps on the line.
You'd have to put a cutoff on the I guess I don't understand I don't think we have laid out what would actually kill power to the main system. We don't have an automated way of doing that currently. So if the system got too hot and it reached whatever our preset point was for self-preservation mode, we'd only have a mechanism for having it automatically turn off. We haven't determined what that is. Because right now we have a push button on a breakout board.
Yeah.
So some kind of thermal breaker.
Yep.
Yeah.
But we could put it on the select lines that are powering certain components, and in that regard, you could use the PSU. But I'm just thinking out loud here because I bought a giant PSU that's 1,000 watts, but it's rated at I don't know what amps, but that's spread out among different voltage lines. I don't know if we have enough on the 12-volt line to deal with all of our main system stuff and these Peltiers. That's a lot of power.
Mm-hmm.
Oh no, we can't. No, we cannot use the PSU. We absolutely cannot use the PSU because that adds the heat required to run the Peltiers back into the loop. We have to keep that power out of the loop. So this has to be
completely somehow outside of the enclosure.
And then, but we can't do that because the enclosure is already designed. We can't change the design. So, yeah, this is going to have to be a separate PSU.
Could we use a Shelly?
Like
a what?
Sorry, what's that?
Could we use one of the Shellys that are used in smart home? Because with that we can cut the power lines. And it almost has anything that we might need according to controlling it.
What is a Shelly?
I'm going to just take a look at shelly.cloud. SHELLY.
Shelly.cloud?
Yeah.
I have so much crap in my upstairs right now. I bought a bunch of home automation stuff to do just that. Kill switches for the printers.
What is this?
These are Gobi. They're basically a Bluetooth Wi-Fi enabled plug-in. But
yeah, okay. We need more power than those little plugs.
Well, I think it's just the architecture is what Christian's referring to. There's something out there that can you could work with and actually program.
Yeah.
For home automation.
Yeah. Okay.
Not this specific example.
So we need an external power supply aside from the internal PSU. That's what you recommend. Okay.
Yes, and I would also recommend having 2 independent power cables. Let's not try and have one convenient plug-in. And I say that because as soon as you put a junction box in this and try and have a user do their own electrical work, it just increases the chances of them screwing it up and burning down things. And I don't know what the local jurisdictions are, the rules are in Europe, but I imagine they're stricter than here in the US. So I think we should leave it as 2 separate plugins.
Yeah.
Before we had the idea, we take the main plug-in that we're using to power the PSU, we split it in a junction box, and then we run another separate cable down to the climate controller, which is nice in a clean setup, but that requires the user to do actual electrical work, and I don't know if we want to do that. I would do it. That's probably how I'm going to do mine, but I don't know if we want to have regular folks try to do that.
I get your point.
Additional power supply. No.
Yep, I didn't get that.
More stuff to add.
Okay, we do not have to answer this question today. Let's think about it. Yeah, guys, it's now 7 o'clock and we have 2 hours of dev meeting. Are there any open topics for you? Otherwise, I would say we round it up for today.
Okay.
Anyone? Anyone, any point that he wants to bring up? Andre, we didn't hear anything from you. Andres. Hello? Mr. Rudberg? Oh, okay, he probably muted us. Okay. Anyhow, so yeah, thanks again, guys, for showing up. We'll keep connected in the channels. Yeah, and we post day by day, on a day-by-day basis. Okay, I will close now the recording.